Hello everyone, welcome back to the fourth day of CCNA. It's really good to see you taking this session. Normally people does not make it so far. They start with enthusiasm, but it does not last it long because they have to give some time for learning and they don't want to do it. Actually, learning takes time as well as money. In our course, money does not matter because it's free, but it takes time. If you do not change your schedule and can't give 2 hours a week for your skills development, it's very difficult. There will be no progress in your career. You will be wherever you are. So just fix your schedule. You are going to spare 1 hour or 2 hours, right? Whatever you want. So just fix your schedule that okay, on Monday between 9 p.m. to 10 p.m. I will give 1 hour and another an hour will I will give it on Thursday 9 p.m. to 10 p.m. So obviously you have to check your schedule that at what time you are free. So just fix your schedule. That is very important. If you do not fix it, what happens that you think that okay, I will do it tomorrow, I will do it in the morning, I will do it in the evening, and the week completes and I upload the video, I do my live session, but still you do not complete it and you fall behind. So it's very important to complete it everything with me. Okay. So just fix your schedule. That's very important part. And then only you can improve your skills and your career will be in progress. Okay. So let's go ahead. What are we going to cover today? So today we are going to cover network topologies and then we will have a look on the IP address. So in IP address, first we will just have a look on the IPv4 address. Okay, because there are two types of addresses, IPv4 and IPv6. So first I will just look onto the IPv4 address, that how they are and a lot of things I will discuss. And then I will just have a look from binary to decimal or decimal to binary conversion. You might have forgot, but I will just give you a glimpse so that you remember it because it is going to highly used in the IP subnetting. So I will just give you how to a brief that how we use it. Then we will discuss about the IP addresses classes like class A, class B, class C, and so on. And then we will also understand some priority bit concepts. Some of the people also call it as a first octet concept, but anyways, they are the same thing and we are going to discuss. And then we will see some IPv4 address representation, that network bits, host bits, that which of the part is network and which of the part is host bits. Okay, so let's just start. There are different type of network topologies. So let's take the first one, which is our bus topology. So in the bus topology, what is happening? There are a lot of computers. Suppose this is our one of the computer. Okay, and first we have to take the bus like one wire. Okay, and in one wire there are all connections are like that. Suppose this one computer is connected, there is one more computer that is connected like that, and one more connected like that. So they are all just connected via one cable. So it can be normally RJ45 cable, or we said normally says as a LAN cable. Okay, so this is the way of the bus topology. But what is the problem in this topology? That if anywhere the cable is connected, suppose this cable is connected over here, then these computers are not able to connect to this side. So this is the big problem in the bus topology. There is a one more problem in the bus topology, that if any of the computer is communicating, suppose this is computer A, B, C, D, E. So if computer A is communicating with E, it means that our this line is busy, means our traffic is busy, and in that case another computer cannot send the traffic. Suppose A is sending to E, it means that our line is busy and no other computer B, C or D will be able to communicate. So this was a big problem in the bus topology. So that's why we do not use it much and we just switch to another topologies. So let's take another one, that is the ring topology. So ring topology is very much clear from the diagram here, so that all the nodes are connected simply in the ring like that. Suppose this is computer 1, 2, 3, 4, 5, 6, right? So that's how. So there is a one thing that we are having the redundancy. It means that there is a two-way to communicate this one. But if you talk about the old system where there are these hosts, means these are all our computer, like this is computer 1, 2, 3, 4, 5 and 6. So in that case they used to have a technology called as the token ring. So it was just communicating only in the one direction. And what was happening, that when one of the computer is communicating, another computers were not able to communicate. So that was the problem in the token ring communication. But ring topology is very good. Right now what we are doing, we are using routers or switches in that case. So they are very much helpful. Even we are using redundancy in that case. Suppose we are having switch 1, switch 2, switch 3, switch 4, and if they are connected on the ring like this, so we are having the redundancies. So suppose any of the link goes down, suppose this link goes down, in that case if switch 3 wants to communicate with S1, it can communicate via this one, right? Or if this link goes down, then this might be working, this previous one, so the traffic can goes via this link. So either we can use switch or router, then it works very fine. But whenever we talk about the old technology token ring, then it was not much useful. But obviously right now we are using this ring topology very much, but in case of routers and switches. Another topology, that is our star topology. So star topology is also very much clear from the diagram, but let's understand, because they are not just a computer. Now what we are doing, that we are just taking a center location, that is normally a switch, and from switch we have already seen in the previous session that switch is having different number of ports. So it depends on the configuration, that which type of switch you have purchased. So it is 24 port, 48 ports, or larger number of ports in the switch. So the more the requirement, the more costly switch you purchase, and the more number of ports you get in that switch. So just there's a one switch, and from there you are have just connecting the computers. So suppose you via LAN cable, or you can also use some access point in between, and then you can connect our uh, via Wi-Fi, you can connect the computer or mobile phone. So this is our star topology. That's the one center point, and from that one center point we are communicating the different hosts. So that is our star topology. So these are the quite simple topologies: bus, ring and star. Sometimes they become very complicated, like you see that this is called as a mesh topology, that any host is connected to anywhere, or we can say that all the hosts are connected to all of them. Suppose you talk about this host number 1, this one, so this is connected to all of them. This one is connected to this is connected to this is connected to this as well, this is also connected to this host, and this is also connected to this host. Means all the hosts are connected to all the other hosts. So this is called as a mesh topology. Sometimes people also call it as a full mesh topology, but actually full mesh or mesh topology are almost the same. Another topology is the tree topology. So in the tree topology, I recommend that tree topology is very no very much used nowadays. In fact, not tree topology. We have new terminology for that one, that is called as a spine leaf. So what is happening in the spine leaf actually? So let me clear or go with, let's go to the top. What is happening in the spine leaf? There we are having the layers. Like suppose this is router 1, This is another router 2. Okay, so they are in the same level, or we can say that these are core routers. And now further, okay, let's go ahead. And now they are further connected to the one more router. Suppose this is connected to the R3 and R4. So R3 will be having connectivity with R3, R2 as well as from R1. Similarly, R4 will be having connectivity with R1 as well as from the R2. So any of the router goes down, either it's R1 or R2, so still our traffic is not being impacted. We have the almost zero downtime in these cases. So this is the very beneficial, and normally we are using this one. And after that one, suppose this is, we can say that this is a core layer, and this is the one more layer, we call it as aggregation layer, aggregation. And after that we can call, say, as a access layer. So there we can have multiple switches or even routers. That's also depends on a requirement or whatever the customer has suggested. And now again it will be having the connectivity like this switch will be connected, this is switch 1 and this is switch 2. So switch 1 is having connectivity with R3 and R4, and the same time switch 2 will be having the connectivity with R3 and R4. So this is the case that when any of the hardware goes down, our traffic is not impacted, and the further you know that we are having the host over there. So this is another way of the communicating. So this method is known as the spine leaf architecture. This is similar to our tree topology, but little enhanced. And so let me clear this one. And one the remaining was that one hybrid topology. So in case of hybrid, what happening that we are sometimes we are creating the rings that suppose we are having the core layer. So for the core routers, we can create a ring R1, R2. These are very strong routers, very high switching capacity. R R1, R2, and R3. We can create a ring like this. And after that one, we can create, if we want, then we can further create one more ring using this one. Or we can simply use our, our access and core layer. Like suppose here, this is connected via this, and this is also connected via this. And then further, we are using the tree topology like this. So that's also we can do. So that's, we call it as a hybrid topology. That's the thing. There is no fixed rule on the network topologies that which topology we use. It just depends on totally the requirement, that what is your requirement. Based on the requirement, our solution architect suggests, and then we deploy that network topology. But these are the major types of network topologies we use in the network. So let's move to the IPv4 address. So IP address, in fact, there are two types of the IP address. The one is IPv4 and another is IPv6. So today we are going to learn only IPv4. IPv6 we'll learn later on. So IPv4 address is a 32-bit address. So if you see, count, you can count these bits 1, 2, 3, 4, 5, 6, 7, like so. You will having total 32 bits. So obviously it is very difficult to remember these IP addresses or have a look on these bits. So what they did actually, they have just divided these 32 bits in the four parts. So obviously 32 bits are there. If you divide in the four parts, then each of the part will be having how many bits? 8 bits. So these 8 bits is called as the octet. So if you remember the chemistry in the your school or colleges, so our oct is called as number 8. So that's why this term came as a octet. So if you don't know the chemistry or previous, then don't worry. Just keep in mind that 8 is our oct. So based on that one, we are using the octet. So we are just dividing this IP address in the octet. So let's just divide this one. So if we split into the octets, then if we count it here, this is our 1, 2, 3, 4, 5, 6, 7, and 8. So here is it, up to this one we are having the first octet. So this is called as our first octet, and this is called our what? Second octet. So these are also the 8 bits. Let's count it. 1, 2, 3, 4, 5, 6, 7, and 8. So obviously there are also 8 bits, and that is called as the third octet. And the last one calls as the fourth octet. So this is the concept of the octet. For the simplicity, we have divided this number to the our octet. But obviously it is also not so easy to remember these binary bits, right? So for that purpose, what we just use the dotted decimal format. What we use? Dotted decimal format means that we convert this IP address in the decimal. This is our binary number. We convert it to the decimal number. Decimal number are very simple. What we normally use from 1 to 10. So that is our decimal format. So before converting this binary number to the decimal number, let's just learn how to convert this one. Okay. So I have just taken a simple, not taken, in fact, I will take, let's take one simple example of the 29. So 29 is our decimal number. Okay, let's suppose that 29 is decimal number and we are going to convert it into binary number. So for the converting the binary number, what we do, we just draw these lines like this and just try dividing by 2. Why we are dividing by 2? Because binary is having only 2 bits, 1 and 0. So number of bits, how many? 1 and 2. Count how many bits we are having, that is 2. And which are the bits are 1 and 0. So count is 2 because we are having 2 bits, so we are dividing with the 2. So let's divide with 2 to the 29. So then we get the 2 ones are 2, 2 fours are 8. Oh, 2 fours are not 8, sir. 2 fours are 8. So we get it as 14, and the remainder will be 1. So whenever the whatever will remainder, just write in this field. Okay, now let's divide 14 again via 2. So we get it as 7, remainder is 0 this time. And let's divide 7 again via 2. So 2 3s are 6 and remainder is 1. 2 1s are 2 and remainder is 1. And now we divide it once again. So let's put it 0 here and let's put 1 on this side because that is our final answer. Or we can say that we don't divide via the 2 because only 1 remaining, then simply put it on this one. And whenever we are writing the binary number, we are just always writing from the bottom to top like this. So the binary conversion of 29 will be what? Starting from bottom, that is 1 1 1 1 1 1 3 by 1 and then 0 and then 1. So 0 1. So like that, we first take this one 1, then 1, then 1, then 0 and then 1. So this is the binary conversion of the 29. So 29 is our decimal number here, decimal, and this is our binary number. Now what we do, we just try to do the reverse. What are we going to do? We are going to do the reverse, means from binary to decimal conversion. So let me write it, this number 1 1 triple 101 again, 1 1 1 0 1, right? So now let's try to calculate our decimal number. So this is our first bit. We just always take from the this way, this side. I think we know the mathematics, we always start from that side, right? So this is our the first bit, or we can say that the 0th bit. What is this? Is 0th bit. Place of this 0. This is our first bit, this is the second bit, this is our third bit, and this is our the fourth bit. A number is starting from this side, 0 1 2 3 4. So the 0th bit is 1, first bit is 0, and the second bit is 1, third bit is 1, and fourth bit is 1. Whenever we try to convert it into the decimal, what we do? We put the power of this one, 2 to the power the place of that bit. So the place of this bit is 0, so we calculated this as 0. This is 2 to the power 1. Why 1? Because this is the place of that bit is 1. After this one, we calculate it like this, 2 to the power 2. Here we write like this, 2 to the power 3. And here we will writing 2 to the power 4. Clear? What are we going to do next? We are just multiplying these numbers via our bits. Means till now what we have calculated, these are the decimal numbers, but for that we have to multiply with the original bits. So first let's calculate the 2 to the power 4. 2 to the power 4 is what? 16. 2 to the power 3 is 8. 2 to the power 2 is 4, and this is 2, and this is 2 to the power 0 is 1. I think you know mathematics very well, that 2 to the power 0 is 1, or any no number of that power is 0, then that is 1. If you don't know, then you can search in the Google, you will get the answer. Now what we are going to do, we are going to multiply this number via the original bit. What was the original bit? This one. So 16 multiplied by 1. 16, let me change the color again, otherwise you will get confused. Let's take black. So this is our bit, that 1 multiplied by 16 plus, what is the bit here? That is 1 once again. So 1 plus, what is this place bit? That is again 1 plus, what is the bit here? 0. And what is the bit here? 1. Like this. Okay. Now just add these values. So 16 ones are 16. 8 multiplied by 1 is 8. 4 multiplied by 1 is 4. And 2 multiplied by 0 is 0. And 1 multiplied by 1 is 1. Now we have to add, right? We have already put the plus sign over there. So just we have to add all these values. And what we get it here? 16 plus 8, that is 24. 24 plus 4 is 28. And 28 plus 1 is 29. You see, what are we getting? We are getting the same result. So that's how we convert from binary to decimal conversion. So obviously I have just given only one example. I'm not going to spend too much time on this one. If you are weak in this conversion, then you can watch this video once again. What I have teach, you can just push back and then come back here. And if you are good at it, that is not a problem. We are going ahead. Okay. And if you are really weak, then you can practice more on this one. Okay. So we are going to calculate some of the binary numbers. So I'm just taking this first one as like 00. Why we are calculating this one? Because I'm calculating this number as a previous number. In the previous one, we are having this number, right? So I'm just trying to calculate the decimal number of this one. So I'm taking the first octet, second octet, third octet, and the fourth octet. So I'm taking these values and trying to calculate the decimal of these numbers. Okay. So this is our first octet, what I have taken there. Let me change the blue color. Where is blue? My blue color is always lost. Okay, here it is. So the same, this is the place is 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and this is 2 to the power 7. Or for the simplicity, you can also write because you know, right, this 2 to the power 0 is what? 2 to the power 0 is 2 to the power 0 is 1. So you can write 1 here, 2 here, 4, 8, 16. These are the value of this one, right? 2 to the power 4 is 16, 2 to the power 5 is 32, and 2 to the power 6 is 64, and 2 to the power 7 is how much? 128. Now what we have to do, wherever there is a 0, we will skip those values because if you multiply 0 via 128, you get 0. If you 0 multiply 64, you get 0. So we will take only those values wherever we are having 1. So 32, 16, and 0 we will skip it. 1 is 4, and 1 is 2, and this is again 0. So plus add just plus these values. So this octet will be giving us how much? 2, 4, 6, 6, 6, 12, 12 plus 2, that is 14, and 1, 1, 2, 3, 5, that is 54. Let's take the second octet. So again, we are going to take 128 here. This is 64, not 32. This is 16, and remaining are 0. So let's add these values. So 6 to 8, 8, 8, 16, 6, 1, 1, 1, 2, 1, 3, 1, 4, 4, 2, 6, and that is 1. So this is coming as 166. So similarly, if you could just calculate the remaining two octets, you will get the value. So I'm not going to calculate, I'm just going to copy and paste this one values. Okay, so what we calculate, we will get these values: 54, 176, 13, and 200. And okay, we have done some calculation mistake. I think that should be 176, and the remaining will be 13 and 10. So if you calculate this one, we will getting as 13, and this is you are getting as 10. Oh, 210. That's great. So that is 210. So let me write it once again, although. So that is 8. Here it is 4, and here it is 1. So 8 plus 4 plus 1, that is 13, and this is 128 plus here it is 64. Why we are writing 64? Because in this place we are having 2 to the power 6, and 2 to the power 6 is 64. Similarly, 1 here, if you go at the top, then you see that this is 16 to the power 4. So we are 16 plus we are having 1 in this place. So that is our 2 to the power 1, that is 2. So that's how we are getting that 210. So we can represent this number like this, right? We took the binary number total, that was 32-bit, then we divided it into the octet like this, a smaller octet, and then we write this octet in the decimal format like this. Why we are writing in this decimal format? Because this is a little easy to remember. I don't say that this is very easy to remember, but obviously it is quite easy to remember rather than this binary number, right? So that's why we write it in the decimal format, and that's also divided into the 4 octet. Okay, so let me just give you one example that how actually we define our IP address in the real system. So let me take one example. Okay, so whenever you want to check any computer, the IP address of your system, you can simply write the command IP config. It will show you the details of the system. So this is the IP address of my computer, IPv4 address, right? So 192.168.29.52. What is the subnet mask? That is 255, 255. I think we haven't discussed about subnet mask, so don't worry. We will discuss. And this is our default gateway, that is 192.168.29.1. If you want to modify these IP address, because normally these addresses are getting automatically from the DH server, right? So for that, what you can do, if you want to change the IP, you can go to our network sharing center. The shortcut is to write this ncpa.cpl. It will redirect you directly to the your LAN Ethernet adapter. You see that network connections. I'm using this Wi-Fi, thanks 5G. So if you want to see the properties of this one, you can have a look on this one. Okay, and that you can just go to the IPv4 address like this. You can go to the properties, and if you see the options here, that you see that right now I have option selected as obtain an IP address automatically. Okay, so what is happening? It is going to the our server, and then it is getting the IP address automatically. But if you want to use static IP, we can also do that one, although it is not recommended to use that one. But I know it, that what is my IP address, because I know that my router is always assigning IP address from 1 to 255. So not 255, in fact 1 to 55 only. 52. 55, I think. I don't, but I have tried some of the IPs, so I'm just trying to put those IP once again. 192, 168, and then that is 29, and then it is, let's try 5. Earlier it was, you remember what was the IP earlier? It was 52. Okay, now what I'm doing, I'm just changing it to the 5. And if you observe that this subnet mask will be filled automatically. No? Oh, yes, now it is. So 255, 255.0. So don't worry, we will discuss. And it is very important to put the default gateway in that. If you do not put, then we cannot use our internet connection. So my default gateway, I already know it. I have seen it from here. I will put the same as it is, 192.168.299.1. So let's write it 168.29.1. Okay, and let's put it okay. It's giving some warning, not a problem. Now I just close it. So it will just no just it will assign new IP, so internet will fluctuate and it will come back after some time. So now let's see our IP, that what is our IP address. Earlier it was 29.52. What is my IP address now? You see that it has been changed now to 29.5. So that's it about the IP address. You seen that how we use our IP address and why it is important. If it has been in the no, binary address, then I was not able to remember that what was our IP address, and I could not have. Well, obviously I could have by writing in the paper, but what was not so easy to remember that IP address, like 192.168 or something like that one. So that's why we use our decimal format. So now what is happening actually, our these IP addresses are divided into the 5 classes. What is happening? They are divided into the 5 classes. What is these classes? These are very simple. We first class is class A, class B, class C, and class D, and class E. So these are the 5 types it is divided. How it is divided? It is being divided based on the first octet decimal number. So if our IP range is between 0 to 127, you see that starting IP is in between range of this one, 0 to 127, 255.255.255. How it is being changing actually, let me just clear you. Suppose we are having the big no, IP address. So obviously that will be having, as we seen, that it will be having 8 bits of 0. So this is, I'm just writing only 1 bit because this is all 0, so you can write 8 times. Another one, I'm just writing the last one. Okay, remaining all I'm saying just simply only 1 0. So in the last octet, what is happening? It will be having 8 zeros, 0, 4, 1, 2, 3, and 4. So obviously this will be replicated in the remaining as well, because it will be having 8 zeros in the first octet, 8 zeros in the second octet, and 8 0 in the third octet. So but for the simplicity, I'm just, or to convince you, I'm writing only the last octet. So this will be our 0 bit. And if we want to change the IP, or we can say the first IP, what is happening? The first number is changing. That bit will be 1, right? So that will be our first IP. Or if you do not understand like this, then you can just simply take our IP in the decimal only. We will discuss only the decimal. We will do not go to the binary. So what will be the first IP? That will be obviously 0.0.0.1. What will be the next IP? 0.0.2. This number will be increasing. 0.0.0.3, 0.0.0.4. Up to what it will increase? It will go up to when these all bits are 1. So when all the bits are 1, then what is happening? This will be 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, or 2 to the power 3. And if we add all these values, then the maximum we can get, that is 255. If you don't trust me, you can try by yourself. Just take a binary number of the 8 bit and try to calculate its decimal number. If you calculate its decimal number, so that will be coming as 255. So the maximum number we can go into the first octet, that will be up to 255. So that will be 0.0.0. Once this one last octet is filled, now what will be happening for the next IP? It will try to fill the third octet. Now the fourth octet is full because it will start from here. Start filling. It will continue from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and up to 255. Now it will start filling our second octet. Sorry, third octet. So what will be happening now? 0.0.1.0. What will the next IP? 0.0.1.1. 0.0.1.2. Next it will be 0.0.1.3, 1.4, and it will continue up to what? 0.0.1, sorry, this is not 0, 1.255. What's next? Now it will go to 0.0.2.0. Now it will happen 0.0. Oh, I'm just taking 3 zeros here. 0 and 2.1. 0, 0, 2, 2. That's happening. You see 0.0.2. That's how it will continue. 3. Continue up to what? 0.0.2.255. Now what will happen next? It will go to the this 2 will the second octet 2 will be changed to 3. It will be like 0.0.3.0. So similarly it will be happening, and now it will this second octet will also be changing up to the 3, 4, 5, 6, 7, 8, 9, 10, and the condition will come when it will be like 0.0.255.255. What will happen now? Now it will shift to the second octet and it will start like this: 0.0 0.1.0.0. What will be the next IP? 0.1.0.1. So you see that how the numbers are changing. This is very simple to our decimal number, right? Numbers are changing like this: 1, 2, 3, 4, 5, 6. Let me make some space. There's a very hotspot now, so let me clear it and then tell you. So if we take the number like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once our 10 reach, we start like this: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, and then we go to the back and the 2, 0. Right? So after the start, how much? 2, 1, 2, 2. The similar thing we are doing in the binary. That once this octet will be full, the fourth octet, then it will go to the third octet. Once this octet is full, it goes to the third octet. Once third octet is full, it will keep incrementing our second octet. Once second octet is full, it will keep entering into the first octet. So what is happening in the class A? Class A range is from 0.0.0.0 to 127.255.255.255. So the only difference is in the first octet. From the first octet itself, we can just identify the IP address that from which class it belongs to. So if the first octet is from 0 to 127, it means that is our class A IP. If the first octet belongs to 128 to 191, then it is our class B IP. If it belongs to 192 to, or we can say that the range of the first octet is from 192 to 223, then we say it as a class C IP. If it is 224 to 240, or in fact not 240, 239, then it is class D. And further 240 to 255, that is our class EIP. So you just have a look on this IP address and you can just simply tell that which in which class it belongs to. Let me just give you one example. Just tell me that which IP, no, which class it belongs to. Let's take an IP address of 87.5.22.9. You see, know that which class it belongs to. It belongs to class A. Why it belongs to class A? Because we just observed the first octet. First octet is 87, and it, lies between 0 to 127. So as it lies in 0 to 127, it belongs to class A. Let's take one more IP address. Blue. So let's take one IP address of 129.20.30.5. Which class it belongs to? You have to look on the first octet, that is 129. So 129 comes between 0 to 127. No, because it does not 129. It does not come. It comes in the range of this 128 to 191. Obviously, if we start from 128, the next number will be 129, 130, 131. So 120, this 129 lies between 128 to 191. So this is a class B IP address. If you take any IP like this 192, 168, what we have just taken an example that was 29. We just assigned an IP in my computer, right? You just observe that was 192.168.29.5. So that IP address belongs to the class C IP address. Why it belongs to class C? You have to just look on to the first octet. First octet is how much? 192. So where it goes 192? You see that 192 to 223 belongs to the class C. So that's why this IP address is going to the class C IP address. So that's how we use our class C IP address. Now you will be having one question in your mind, that how you are assigning that this is only, why this is only 0 to 127, or the class B IP address is to this what class B is 128 to 190, and why is like that, right? Why we do that? So there's some concept called as a priority bit concept. Priority bit concept, or some of the people also call it as the first octet rule. First octet rule. So what is happening exactly? In the class A IP address, what they are doing? They are always setting the leftmost bit as a 0. Means if you talk about the first octet, then first octet we are having these bits 0, 0, 0, 1, 2, 3, 4. You are having these 8 bits in the first. These are the first octet bits. These are the first octet. And what they say in the class A IP address, our first bit is fixed as 0. That you will not interfere with the first bit. Means this is always 0. So what can be the maximum value of the remaining? What can be the maximum value? Because this is fixed, the maximum value, for the maximum value we can put it as 1, 1, 1, 1, 1 and 1. If we add these values, if we convert the decimal number of this one, you get maximum number as 127. Don't trust me? You can try by yourself. Just convert these decimal numbers. You will get as 127. So that is called as the class A IP address. So there's a rule for the class A that is belongs to the 0. Similarly, what is happening for the class B? The first 2 bits are fixed as 1, 0. How they are fixed? Suppose let's say that these are the bits. And in case of the class B, this first 2 bits are fixed as 0 and 1. So this is written as 0. Let me try it as 1 now, or let me change the color as well. So let's write it as 0 and 1. So the first bits are fixed 0 and 1, and the remaining you can change. So maximum what you can do, you can put like this. So that's the remaining range. So that's how we get our number. So the number you get as 0, 1, This is our bits. You can convert to the decimal number of this one. You get the range of the class B IP address. So that's how it is happening. For the class C, the priority bits is 1110, and the class D, the priority bits is 1110, and for the class E, all first four bits are the 111. So these are always the leftmost bit. If you don't understand this one, not to worry too much. It's just for a knowledge only our job will be only done with the looking on the decimal part of that one. You just look onto the decimal number, you see that this is 225, that it means that 225 belongs to our class D IP address, because this lies in the range from 224 to 239. If the number is from 200, so 200 where it comes, 200 comes something in between 192 to 123, right? Or let me change the color, green, you might not see it. So the 200 will be coming somewhere in between 192 to 223, right? So that's why this belongs to the class C IP address. So just look on the first octet, you can simply recognize this IP address belongs to the which class. This is quite complicated, not to worry too much. These are just very basic concepts, and you do not use in the practical lives, and you are having calculator for that one, or you also use our online tools for this one. But if you are going for the CCNA exam, then definitely you must learn this one. If you don't learn, then sometimes but only one or two questions you may have to leave, that's it. But it's really try to understand. If you still don't understand, just watch this video once again, because if you watch again, then definitely you learn more. Okay, not a problem. Or if you have any questions, then still we are going to meet on Saturday. You can ask me anytime. Okay. So based on the uses actually, so our class A, class B, class C are normally being used in our LAN and WAN. So LAN and WAN, we have already discussed our local area network and wide area network. So our only these IP addresses are being used for this purpose. Class D is used for the multicasting. So multicasting is normally used in the IPTV, or there are some other features also for the multicasting purposes. So, or Netflix or video streaming devices, they also use our multicast IP address, because there are a lot of subscriber watching the same streaming. So that's why they use multicasting. And the class E is reserved for the research and development. So nobody use that one. If anyone is doing R&D, they just use this class E IP address for their purpose. Okay. So IPv4 address is actually no part of some of the network bits and some of the host bits. What is this actually, network bits and host bits? So normally we are having the 4 octets, right? So let me just clear you the description here. It tells about the network of which host will be the part. It helps to maintain information about the routes, and this is the identifies the individual host. So network is actually, it's like your state or the city where you belong. So this is your network, right? So this is your state. So suppose if you are in the India, then Delhi is a state. Then it shows that you are from in Delhi, and in Delhi what is your house number, so that your house number is like a host ID, right? Or you can say that our pin code number, something like that. So that is your host ID number. So first you have to identify that on which network you belong, and then inside that network there is one our house number. So that is you might be your host ID. If you don't understand, not a problem, you will just take more examples, you will learn. So this is just understanding. If you don't understand, nothing to worry about that one. Okay, but just to keep in mind that we are having some network bits and some host bits. So in the class A IP address, because we are having the 4 octets, the first octet, the second octet, the third octet, and the fourth octet. So in the class A IP address, the first octet belongs to the network, and the remaining all belongs to our host. Correct? So if we calculate the number of network and number of the host, then we can calculate of the 2 to the power number of bits. So in the class A, we are having the 8 network bits, because in the one octet we are having only 8 bits here. So we can calculate 2 to the power 8, that is going to give you 256. So that's why it is as the 256 networks in the class A. And if we talk about the host, how many hosts it can be, so that is the remaining bits, that is 24 bits. So we can calculate via 2 to the power 24, and that gives you this value, that is very high value. So there will be very large number of hosts in our class A IP address. Okay. Next is our class B. In class B, they are the equal number of network bits and host bits. They are 16 network bits and 16 host bits. So if you calculate the number of networks, so it will be 2 to the power number of network bits, they are 16. So 2 to the power 16 value is coming as 65,536. Similarly, it comes the same value for the host bits because it's having the same bits, so to the power 16, that is also coming the same value as 65,536. If you talk about the class C address, so in the class C address, we are having the total 3 octets, first 3 octets for the network bits and the last octet for the, or fourth octet for the host bits. So here the networks are very high. We are having the same number what we are having the host here. So the same we are having here. So the number of networks we calculate 2 to the power number of network bits. So network bits are 24 here. You get it, write it here 24, and you get the value. Obviously you can use your calculator to get this value. You will getting this value. And if you talk about the host, then we use 8 bits here, and that is going to 2 to the power 8, and I think you can simply calculate 2 to the power 8, that is getting you 256. So this is just concept of the network and host bits. Clear? I hope it will be clear. But still, if it is not, then you may ask in our live classes that whatever doubt you are having, because we are going to discuss all these things once again on Saturday. And if you are watching this video quite late, our live classes has end, then you can write in the comment section. If you have any doubt, I will get back to you, because I keep on watching these comments. Okay. So that's it for this session. We will learn subnetting in the coming sessions. So obviously subnetting is a quite complicated topic. So I will record 2 or 3 videos, and then I will cover total subnetting. Okay. So that's it for the day. See you in the next session.